In the next part of this lesson, we're going to be looking at trinomials, and we're actually going to start off by looking at a special type of trinomial, they're perfect square trinomials. And we're going to notice that a plus b squared is actually a squared plus 2ab plus b squared. And so what we can do, if we ever have a binomial squared, we can think it's the first thing squared at the beginning, so a squared, the last thing squared at the end, and then if you multiply a times b and then multiply it by 2, it will give us this middle term. That's how we learn to multiply this out. So now what we're going to do to factor is if we have a perfect square and another perfect square, and if this other term is the square root of this, so a, so the square root of a squared is a, and the square root of this, which is b, and then it's multiplied by 2, then it's a perfect square and it can be factored into this binomial. Same idea, if you have a minus sign here with a 2ab, it will just be a minus b squared. So here's a couple examples. This is how you can look at this. Is the first thing a perfect square? It's kind of what you ask. Yes, it's a perfect square. It's x squared. If you square x, you'll get x squared. Is 25 a perfect square? Yes, that's 5. Square root of 25 is 5. Is this middle term 5 times x times 2? 5 times x times 2. Is that this middle term? It is. It's 10x. Since those three things check out, those three things are a perfect square here, and this middle term is the square root of 5, the square root of x squared, which is x, times this, and then times 2, then it's a perfect square. So since we see that, we can just say this is x coming from here plus coming from here 5 squared. This next one is going to be similar. I see there's a 4 here, so first thing I'm going to look at is there a common factor? 4 goes into this and this, but doesn't here, so there's not. And so we think, is this a perfect square? It is. This is 2x. If you do 2x squared, you get 4x squared. Is this a perfect square? Yep. 7 squared is 49. And so if we took 2x times 7 and doubled it, multiplied it by 2, would it give us this term? 2 times 7 is 14, times 2 is 28. So it does. Since those three things check, we know we can have 2x coming from here, minus sign coming from here, and 7, and the whole thing squared. So those are a special type of trinomial. They're perfect squares. They have to fit that special form. They will come in handy later when we are solving quadratic equations. Next ones are just general trinomials, not perfect square, but general. What we want to notice here, so examine the multiplication to see if we can figure out how to undo the multiplication, which is factoring. So here, this is multiplied 6x squared minus 10x plus 12x minus 20. The really easy ones to see are right here and right here, which are here and here. So this 6x squared came from multiplying these two. So let's focus on the first and last terms first. So where does 6x squared comes from? That's from the 2x times the 3x. So if we think of FOIL, so there's f, the 6x squared comes from the f. The last term, or the L, F-O-I-L, the FOIL comes from 4 times negative 5. So this came from the first two terms, 2x times 3x. This comes from the 4 times the negative 5. Where does this middle term come from? 2x. This came from the O, the outer and inner combined. So if we look at, when we're talking about FOIL, here's our outer, 2x times negative 5 is negative 10, and then the inner, these two, If you take the negative 10 and the 12, you get that 2. And so we should be able to work our way backwards. Might take some guess and check, but we can have an idea of what's going to happen here. So the 6x squared came from these being multiplied. So when we factor, we think, well, how can we get 6x squared? Now the guess and check comes into play because we need 2x and 3x, but we might guess like, well, 6x times 1x gives us 6x squared. And 20, there's different ways to get that. So you could do -1 and 20, or 2 and 10, or 4 and 5. So there is some guess and check involved, but we should be able to get a good handle on factoring these. So let's work through a couple examples. These first two are nice because they just have a coefficient of 1. So we're going to see if these factor. So what we do is we're going to put two sets of parentheses, and we think through this. How did we get this first term? Well, that was the f, the first times the first. So what multiplied together gives me x squared? Well, x times x. And then we thought about this last term, and how can we get this L here? And this is where some guess and check comes in. How can we get a -21? Well, first let's look at getting a negative. In order to get a negative, we have to multiply a positive times a negative. We can't have two negatives. We can't have a positive and a positive. So having a negative here tells us that we need a plus here and a minus here, or vice versa. Now to get -21 specifically, we could do 1 times 21 is 21, or 3 times 7 is 21. And so what we want to do is we want to try these. And so I'm going to put our guesses here in red. We're not sure about this. So let's try 1 and 21. Well, that for sure will have x times x is x squared, and 1 times -21 is -21. It's this middle term we have to look at. And that comes from outer, so x times -21 is -21x, combined with the inner, and that's 1x. Does that get, well, that gives me -20x, which does not give me the -4. So -1 and 21 is not the correct way to factor that. This will go faster once we get better at it. So now let's try 3 and 7. 3 and 7. Let's check again. Our outers is x times -7, and then plus 3x. If we add those together, that does in fact give us -4x. That's what we wanted. And so this is our answer. X plus 3 times x minus 7. I want to tell you a quick hint here. If you're ever doing this, if you had to have opposite signs, because this is negative, and if we worked through and tried in different numbers and we got +4 here instead of -4, so if we got +4 but wanted a -4, all you have to do is switch your signs here. We could switch the positive and the negative. All right, let's look at this next one. We want to factor this. How do we get an a squared from these two? Well, it has to be an a times a. And how do we get a 24? Actually, in fact, let's look back here at a positive. How do we get a positive? We need to multiply two things to get a positive 24, so they could either be a positive times a positive or a negative times a negative. Where we look at that is right here. We need a negative times a negative. If this were a plus sign also, we would have done a positive and a positive. Well, how do we get 24? Well, 1 times 24 is 24, 2 times 12, 3 times 8, and 4 times 6. So we have different options here. If this leading coefficient is 1, if it's 1, all you need to do is look over here and see which ones combine or add together to give -11. 1 and 24 is 25, 2 and 12 is 14, 3 and 8 is 11, and in fact, remember, we're doing -3 and -8, so that's what we want because they add up to equal -11. That only works if this coefficient here is 1. So over here, we can't think through that same scenario. I'm sorry, I put 2, 3, and 8. put 3 and 11, this should be an 8. Because 3 and 8 give us 11. That's why I wrote the 11 there. But a minus 3 times a minus 8. This last one here, we're going to have two groups of parentheses. Again, remembering we always want to try to factor something out in common first. There's nothing in common in these three. So how do we get a 2m squared? Well, it's not like the other ones. We actually need a 2m multiplied times an m. That's our only option really to get 2m squared. Negative, remember if there's a negative here, in order to get a negative at the end, we need one positive and one negative. We might have to change these signs later. We'll just have to wait and see. And then we have an 8 here. How do we get 8? Well, to get 8, we have 1 and 8, or 2 and 4. So let's try some of these. Let's try 1 and 8. I'm a little hesitant to do this because this is going to work, and it doesn't always work out that our first guess is the right one. But as we look through here, we get our 2m squared, and multiplying these two gives us negative 8. Now let's look at these. 2m times negative 8 is negative 16m. Looking at the inner is 1m. That does in fact give us negative 15m, which is that linear term here. And so this is the answer that we're looking for. So that is factoring trinomials. We had our perfect square trinomials that fit the special form, and then we had these ones we just did here.